So you're welcome back. So where we stopped in the last video was changing this back to sex, and so it runs after. Then you can check the data file, the data types, and you see the things that has been changed. So referrals, for example, has been changed to floats. Now encoding categorical variables. Now most machine learnings can't understand, I mean, most models, not just machine learning models, most models can't understand text. So they only work with numbers. So that's why we need to convert categorical variables into numerical form, you know. So one there are two ways of doing it. We have the one hot encoding, and we have the label encoding. The one hot encoding creates dummy variables. So for example, for sex, we have we have male and female inside one column. So what this would do is create a column for male, a column for female, alphabetical order, female first, male first. So everywhere where the condition of female is true, it writes true. Otherwise, it is false. So you are either female or you are not female. All right. So true, false is also recognized as 1 and 0. True is 1, false is 0. So that works. So to do that, we want to create a new a new variable called one um, df1 hot. All right. So the what you use is get dummies. That's the that's the function to use. Get dummies. Then the data you are bringing in, that's the one with double XL. I mean double L. Then we are converting sex and air color. So once we are done, if we run it, then we'll see what happens. So we call the objects that we did the first five. So you can see sex female, sex male, true, true, false, and so on, false, true, true, and so on. For the hair color, where we have black, blonde, brown, and others, you can see true, false, and so on there. So that's what this one makes it easier to work. I mean, to create model with, you know, and even for sake of interpretation, this is also good. Now, however, when your values are if they are if they are ordinal, you really can do this for ordinal, although you can, but it's not for ordinal variables like educational status, where you can where PhD is greater than graduates, greater than masters, greater than, like that. So we need to convert them into values. So for example, where we have A, B, C, we'll have 0, 1, 2. So if A is secondary school level, then it's converted to 0. If B is undergraduate level, it converts to 1. If C is postgraduate, it converts to 2. All right. So I've used income level before, so I'm going to go back and choose educational level. I prefer to copy it that way than writing, because writing I might make it where it is small letters, I'm gonna make it capital letter. All right, and paste here. So here we are introduced to another library here, sklearn.preprocessing import label encoder. So now that label encoder, we are assigning it to LE. So that's the LE we are doing here. Fit transform. So if we call the df excel now, and we run that. Oh, I shouldn't even call everything dot head. That's too much. So already we've done it. So let's see. So you can see educational level, you have 130, 3. So it's already converted to numbers instead of what we had there before. All right, so that's okay. All right, so now that's about transforming from categorical variables to values that our models can work with. So again, you can listen to that section over and over. Now, scaling. This is a very important part as well in data cleaning and trying to get your data ready for modeling. You know, one thing you have to do very, very well and very, very thorough is the data cleaning, getting your data ready. Because now, why standardization and normalization is necessary, there are two reasons. One, when data is not normally distributed, we'll get to that in when we are doing statistics, and when we need to standardize it, they are in different scales. Now, let me show you something. If we are trying to check how weights and revenue and referrals, okay, let me go back to the top. So we see the referrals aspect. So we have weights 57. This is in hundreds and tens, while referrals is just maximum is like 10, less than 20, and then revenue is in thousands. So now imagine that age also is in tens, weight is in hundreds, age is in tens, referral is single digits, while revenue is thousands. So it will be a bias most times to just check, okay, how does this impact our profit, for example, because age is on a different scale, and then weight is also on a different scale, reference is also on a different so it's usually a good practice to standardize these values, so that everybody will be on the same scale between 0 and 1. So we'll see the science behind standardization and normalization now. So standardization, z-score scaling, it transforms values so that the feature has mean equals 0 and standard deviation equals 1. This is what it does. So it standardizes the value such that when you calculate the mean, it is 0 and the standard deviation is 1. It follows normal distribution. This is the formula. I'm not going to bore you with that. All right. So now to do that, we have standardization mean equals 0, standard deviation equals 1. From sklearn preprocessing, imports standard scalar. That's what we need, the module we need. So we put it into scalar, and here we want to standardize age and what other thing did we see the other time? Okay, let's do age and weights. Where are you? Standardization, age. Okay, why this again? Okay, age and weights. All right, now I'm going to copy all of this, age and weights. All right, now the df is not df, it is df underscore excel. Let's do that in excel, or in the double excel. Yeah, you can still do it there. Excel. All right, so once we've done that, we would like to see df underscore excel dot head. I won't forget that. All right, so now let's see where is age. You can see age has been transformed. It still maintains its characteristics, but it is transformed appropriately. All right, so we have age as 0.0, and where is the other one, the referral? Okay, weights. You can see it as well. All right, so the formula that was applied to them is this formula. Now, normalization again, what it does is, okay, for standardization, the exact, I don't want to bore you with it. It's just that the value minus the overall mean value divided by the standard deviation. That's what it means. All right. So for the normalization, the value minus the minimum value, everything over maximum value for that column minus minimum value for that column. That's just what it's doing. So it makes the values or the column or the variables retain their characteristics, but they are just transformed to put all the values, all the variables that are being standardized or normalized on the same scale. All right, so to do that, again, sklearn preprocessing, here minimum maximum scalar, and then again we've used some before, so this time around let's use revenue thousands and revenue double. Revenue thousands and revenue doubled. Of course, I can type it, but just to avoid any stories that touch. That's why I copy and paste. All right, all right. So here I have Excel, and here I have Excel. So after that, I want to check df underscore Excel dot head and run. So you can see revenue thousand, revenue doubled has also been normalized. All right. So to normalize things means to the values cannot be less than 0 and they can be higher than 1. All right. So this in this way, this data is ready for, of course, if we want to use it for model, we have to check for marital status as well. Okay, so we've done age and sex and hair color. So we have to transform for marital status, income level. I think that's all. Then now we can proceed with the modeling. Now, merging data frames. Merging data frames. Now, so let's forget the data sets we have worked on previously. Now we are creating a new data frame, df1 and df2. Now pd.dataframe id 1 2. So we have two columns, id and name, and two rows, 1 2 and Alice and Bob. So we run this and then call this and call df2. Now look at the new data set. We have id 1 Alice, id 2 Bob. ID1, the score for ID1 is 85, the score for ID2 is 90. So let me give you an illustration. For example, the ID is your matric number, your student number, and the name is Alice, and this is a data set from the admissions office. However, from your department does not work with your name, they only work with your ID. So this is the ID and the score. Then you have been given the task to combine the data from the admissions office and data from the departments. So here the common key between the two of them is the ID. So how do you link the IDs with their respective scores? All right, so there are different types of joins. We have the inner join, we have the outer join, we have the left join, we have the right join. All right, so let's see how they operate. So the inner join, it returns only the matching rows from both data frames based on key ID. You can see on ID. So is this on that tells us the key ID? That's the key. So here the key is the ID. For some other data, the key might be matric number or student number or employee number or phone number. Phone number is another unique value that can identify your this could be national identification number, voting number, and so on. All right, so we have df1. This is inner join. So what it does, it looks for the row that has, this is the first one, the first data frame that we supplied it. It looks for the number that has this one, ID1. It comes in and looks for it. Whatever is in that is corresponding to it, it adds them here. All right, so let's see. We run it, then we call. So you can see we have ID, name, and score. That's inner join. All right, for left join, it keeps all rows from the left data frame. That's data. This is the left data frame, whatever we supplied it, and fills in matches from the right data frame too. Then let's run that. Then again, we call it merged. So you see, it's still the same. Everything is most likely be the same output. You know, right join keeps all rows from the right. That's it keeps all rows from the right, then adds the corresponding from the left as well. So we run it and then we call it. So you can see we still have the same thing. Then outer join now returns all rows from both data frames and fills with NA with not available when there is no match. Now we run it, then again we call merged. That's for outer join. So it's still the same thing, but when you have a long data, you would have different outcomes for them. You have different outcomes. This is just an illustration data. Now, concatenation. We've concatenated lists and some other little data structure. Here, we want to concatenate data frame. Now, concatenation means joining two or more data frames together, either row-wise, that's stacking vertically, or column-wise. Row-wise is you are putting them beside each other. Column-wise is you are putting them on top of each other. So row-wise, we just have pd.concat, axis equals 0. If you notice, axis equals 0 has always been representation for row. All right, if you call that df total, so we have, you can see the first data, df1, has Alice and Bob, but it does not have score. The second data does not have name, but it has score. So that's what we have for concatenation by row. Then concatenation by column, it places them beside each other. All right, so pd concat axis equals 1. That's just the difference. Axis equals 0, axis equals 1. Remember, 1 is usually for column and 0 is usually used for row. So this is column addition. It just brings it without asking questions, without verifying, just bring it beside each other. All right. Now, here the last thing we'll be discussing is pivot table or pivot table. It helps you to summarize and group and aggregate data. So we are creating another data set. We have region, product, revenue, and sales. I'm intentionally creating data sets in different forms so that you can see how easy and different forms you can use to do that. But everything with PD, that's with Pandas. So region, we have east, 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 west. I mean east, west, east, west. Then product A, B, B, the revenue, and the sales. So the pivots, creating the pivots, we have PD, the pivot table, data. That's the data frame. Values, the value that we want to summarize is revenue here. Then index region, column product. Index is the row header, the columns is the column header. Then aggregate function, we want to sum it. So if we print it, you can see product is the column header. You can see columns product. So product is the column header, while the row header, which is the index, is region. So it summarized the the revenue for east in A is 100. The revenue for product B in east is 150. So imagine you can try to increase this data set and then try it yourself to see how it's how to understand it, to appreciate pivot tables better. So doing the same thing for sales, if we run that here, okay, we have problem, we have sales, index, region. Okay, so what I should do is this. I wanted to try another form, and so here I'm just going to remove this and make